Cutting Wikipedia's load time in half. How Wikipedia slashed 300 milliseconds of total blocking time. For over 3 years, Wikipedia's mobile website suffered from a major performance flaw that significantly hurt the user experience. A single piece of JavaScript code that took over 600 milliseconds to execute during page load on low-end devices. This long task effectively blocked user interactions like tapping buttons or links, leading to a truly frustrating mobile experience. Users would click or tap, and then stare in dismay as nothing happened for a noticeably long time. This is a deep dive into exactly how the Wikipedia team identified this bottleneck and managed to slice its execution time in half, a 300 milliseconds reduction. With just 2 focused code optimizations, there was dramatic improvement in Wikipedia's mobile speed and responsiveness. The cause: long tasks causing high total blocking time. Browsers use a single main thread to parse and run JavaScript code. This means they can only process one task at a time. So, if a user tried to tap an Add to Cart button while this 600 milliseconds task was running during page load, the browser would be forced to finish executing the long task first before it could run the button's click handler code and update the user interface. The user would perceive this as lag and unresponsiveness. According to research by Google, users notice any interaction that takes longer than 100 milliseconds. That's why Google defines any task longer than 50 milliseconds as a long task, because these will likely cause perceptible lag. To quantify the impact of long tasks, Google created a metric called total blocking time. Total blocking time measures the sum of the blocking time from all long tasks between first contentful paint and time to interactive. The blocking time is any duration over 50 milliseconds per long task. With just the single 600 milliseconds task, Wikipedia's mobile site had a total blocking time over 550 milliseconds. For comparison, Google recommends websites maintain a total blocking time under 200 milliseconds for optimal performance. Clearly, to improve the mobile experience, there was a need to focus on reducing long tasks. Wikipedia took 2 approaches to cut down the total blocking time. Remove unnecessary JavaScript execution during page load. Optimize essential JavaScript tasks. Removing unneeded JavaScript. When profiling the mobile site JavaScript, one method named _enable was taking up most of the execution time. This method initialized expand collapse functionality for sections by attaching click handlers to links with jQueries. Click. For long pages with thousands of links, it added over 200 milliseconds. Even worse, it was redundant. Existing code already handled clicks via a hash change listener. By completely removing this block of unnecessary click handlers, over 200 milliseconds of execution time was freed up with virtually no change in functionality. Optimizing essential JavaScript. The init media viewer method added click handlers to thumbnails to launch a lightbox. With thousands of images, this didn't scale well and added 100 milliseconds plus of total blocking time. This was addressed by switching to event delegation. This uses a single handler on a parent rather than many duplicated handlers on each child. This improved performance while maintaining functionality. Results: 300 milliseconds plus total blocking time reduction. Together, these 2 changes reduced Wikipedia's total blocking time by 300 milliseconds, a 50% improvement for long articles on low-end devices. Real user monitoring showed page load times and responsiveness improved significantly. Taps and clicks were much snappier, especially on budget phones. While more work is still needed, these focused tweaks targeting the worst bottlenecks led to meaningful gains. It demonstrates you often don't need complicated sweeping changes to speed up sites. Eliminating or optimizing a few pain points can have an outsized impact. Key takeaways for your own site. Follow these best practices to cut hundreds of milliseconds off your site's total blocking time too. Profile to identify worst bottlenecks. Remove unnecessary JavaScript first, often the easiest win. Optimize essential JavaScript, e.g. event delegation. Focus on making incremental gains on the biggest issues. Measure total blocking time before and after to quantify improvements. With some targeted optimizations, you'll be able to significantly improve performance and delight your users.